I want to look at the volume between two cylinders. This is a classic problem in multivariable calculus. What I have here is I have in orange a horizontal cylinder and in red a vertical cylinder. The vertical cylinder is, of course, wrapped around the z-axis, and the orange cylinder is wrapped around the x-axis. So the orange one is going to be y squared plus z squared is a squared, where a is the radius. And then the red one is going to be vertical one here. It's x squared plus y squared is b squared, and then b is the radius of the red one. Okay, so what I'm going to do is I'm making the same radii. It's a little easier that way. And we're going to find the volume between them. So the volume, it looks like, if we're going to use dx dy as our limits of, as we're integrating against, then what the integrand is going to be what's going on in the z direction. So what's going on in the z direction, I've called that f of y. So what I've done up here is I've solved for z, and I call it f of y. You can't call it z. Z equals this. Desmos 3D will not let you label or name a function with z. So we're going to use f for solving for z here. And so f of y is this expression here, square root of a squared minus y squared. I say y is greater than 0 for this because what I want to do when I find this volume is I want to find the volume of 1/8 of it and then multiply by 8. Because if you can kind of see that the 8 octants each contain equal part of this. And so what we're really going to do is just integrate in this little part right here. Let me make these translucent so that you can see through them a little better. Translucent. There we go. So we're really just going to integrate f of y. So f of y says y is greater than 0, but also z is greater than 0 because otherwise this would have been plus or minus if we're looking at the part of the orange cylinder below the xy plane. This is the part of the cylinder above the xy plane. So above the xy plane and above the x-axis. So with that said, that's what goes here as our integrand. So the integrand is going to go from the xy plane up to the orange object there. Okay? And so that is that part. Okay, now we want to look at, once we're done with that integrand piece, then we look at what the limits of integration need to be. So I'm going to bring the red one back. And here we go. We're going to look at looking down on the xy plane. And so it looks like x has to go, we're going to do dx first. X has to go from 0 to whatever this is. And this is where x was solved for, so that'll be g of y. And if you want, you can see that it's just that little piece right there. And then y goes between 0 and a, because that is this piece here as well. So I hope that kind of makes sense for how to do this kind of problem with the cylinders. And you can play around with this. If you make one too big, it's going to mess things up. See how it says undefined here? So if the red one is larger than it should be, then if the orange one is larger than it should be, then the bounds are messed up. But the red one, it can go inside the red one, no problem. So I'll leave the Desmos that I used to make this in the comments, in the description of the video.